Okay, we're going to talk a little bit about discrete probability distributions. First of all, let's talk about discrete. Discrete basically means it's a number that will stop. So, for example, we could say how many people are in your family, and that would be a discrete number, 0, 1, 2, 3, so on. An example of a non-discrete distribution of numbers would be, for example, what is your height? So you could say 185 is my height, but then depending on your measuring tool, it could be a lot more accurate. So 185.236, and in theory it could go on forever. So that's a continuous distribution, whereas this is really just to do with discrete numbers. So I'm going to take you through an example. It's actually an exercise out of chapter 14. It's question 13, and the example is, I haven't written it on the board, but basically what we've got two dice, and on the dice there's only 4 numbers, 1, 2, 3, 4 on both dice. And the question is, what outcomes can you have if you throw the 2 dice and you multiply the 2 numbers together? So if we throw a 1 and a 4, 1 times 4 is going to be a total of 4, a product of 4, 1 times 4. So with probability and with discrete probability distributions, the first thing we have to do is set up a probability distribution table. And what that requires us to do is work out all the different outcomes that can happen. In this particular example, we multiply 2 numbers together, and then work out the probabilities for those outcomes. So what you can do is use your tools. You've got tree diagrams, Venn diagrams, Carnot maps, probability logic as well. In this instance, I'm going to use a tree diagram, and I've already done it on the board. So over here, you can see I've said basically we're throwing 2 dice. So my first outcome is what's coming up on the first dice. You can either get a 1, 2, 3, or 4. On the second dice, you can get a 1, 2, 3, and 4. Over here is a list of all the different outcomes then. So basically, if I throw a 1 and a 1, 1 times 1 is 1. So the outcome is a 1. 1 times 2 is 2. These are all the different outcomes that can happen when you multiply those 2 numbers together. What we do then is we've got to work out, well, what are all the outcomes, and I'll put it in a table. This is called a probability distribution table. And in this probability distribution table, what I've got is, first of all, I've listed my outcome. So X represents when 2 numbers are multiplied together, when we throw this dice. In the table, in this first column, I've got probability X equals X. So I'm saying probability that when 2 numbers multiplied together equals 1 is equal to 1 over 16. Okay, so what I'm saying is I'm referring to my tree diagram. The only time 1 comes out is in the first outcome, if you throw a 1 and a 1. Okay, so the probability of throwing a 1 is, the sum, or the product being a 1 is 1 out of 16. I've worked out that there's 16 outcomes. If I add all those up, there's 16 different things that can happen. So 1 out of 16. Probability that when you multiply 2 numbers together you get a 2. There's actually 2 times you can get a 2. You can get a 1 times 2 or 2 times 1. 2 out of 16. So all I've done, I've completed this table of all the different probabilities. I've done it in fraction form, and I think you'll find it easier in the end if you leave these in fraction form, because we're going to have to play around with multiplication and stuff. So leave them as fractions. I didn't try and simplify it all. 2 over 16, I left as 2 over 16 because it will become easier when we try and add these together as well. So we have the same denominator, so we do that as well. One thing we need to make sure of for a probability distribution is that the distribution table, all the probabilities should equal 1. So you may find an exam question where it's just saying it might have one of these left out, and you have to realise that all of these must equal 1, so you have to find the missing probability. Okay, so there's my probability, discrete probability distribution table. Discrete, because they're discrete numbers. Probability, because we're talking about probabilities. Distribution just means how the probability is distributed across all the outcomes, and a table. Obviously a table. Let's see, how do we work out probabilities then? This first question is saying, what's the probability that when we take the product of those 2 numbers, it's greater than 8? Okay, so if I look at my table, greater than 8 means I could get a product of 9, 12, or 16. So all we're doing really is just saying, well, let's add up those probabilities. Product of that we have a product of 9, probability that we have a product of 12, and a probability that we have a product of 16. So probability that we get a product of 9 is 1 over 16. Probability that we get a product of 12 is 2 over 16. Probability that we get a product of 16 is 1 over 16. So altogether, probability that we get a product greater than 8 is 1 plus 2 plus 1, 4 over 16. Okay, and if we wanted to, we could simplify that. 4 over 16 is 1 over 4, but I'm just going to leave it like that for now. You see why we left the same denominator? It's easier to add the probabilities. Next question over here, it says, what's the probability that we get a product greater than 8 given we get a product greater than 6? So what this question is saying is that we know we got a product greater than 6, so we know it must be just out of these numbers. But what is the probability that was actually greater than 8? So this symbol here represents given. It's a conditional. It's called conditional probability. The conditional probability rule is, and you would have come across this in exercise 14A, is that we rewrite this basically saying, what's the intersection of these two probabilities? I've written this over here. Remember, this represents intersection. What's the probability? What's the intersection, sorry, of probability being greater than 8 and greater than 6? Over the probability of this second condition, the probability of x being greater than 6. So when you see conditional probability, you have to rewrite it like this to start with, and then we just evaluate this. So, what's the intersection between greater than, of being greater than 8 and greater than 6? Where do they intersect? Where do they cross over? Okay, greater than 8, greater than 8, and greater than 6. Well, greater than 6 means that you'll intersect when you get greater than 8. So this is really saying, what's the probability that x is greater than 8 divided by the probability that the product is greater than 6? Okay? Probability greater than 8 we just worked out. It was 4 over 16. And probability greater than 6, well, look at our table. 2, 4, 5, 7, 8. 8 out of 16. So altogether, the 16s actually cancel out. 4 over 8, or it's a half. So that's our final answer for that. So what we've done there, just to summarise, sometimes you'll need to use a tree diagram or some other tool to create a distribution table. All the probabilities must equal 1, and to calculate probabilities, we just add the probabilities up. We're going to go on in the next video to look at how we do expected value, so measures of average and measures of spread of this distribution table. It's quite easy, so we'll see that next lesson.